Okay, well, good afternoon, everyone. I think we'll go ahead and get started. My name is John Teravskis. I am with a company called WGR Southwest, and we are out of Lodi, California. And I'm pleased to be able to present this presentation to you today on the post-construction standards plan. And I can tell you're all just excited to be here. This is just going to be a riveting afternoon full of high technical discussion. Actually, we're going to have some fun. We're going to take a look at what this new regulation is about. And the City of Chico, Angela Spain and Richard Burgee were very kind to invite me to come and present on this topic. It's a topic that is of growing interest across the state. Why? Well, as we're going to see, it's a regulatory requirement. But in order that I might address you maybe more specifically throughout the presentation, I'd like to get a little bit better understanding of who I'm speaking to today. So first off, how many of you are actually City of Chico employees or staff members? Raise your hand if you work for City of Chico. Okay, not as many as I thought. I thought maybe they had invited everybody from the office to come, and but good, I'm glad to see we got a lot of non-Chico employees here. How many of you are engineers, work for a civil engineering firm, architects, any architects in the room, developers, okay, contractors, any contractors, okay, a couple, and any other municipal agencies, other cities? Do we got Oroville here? Oroville? All right, welcome. Paradise? I think they're coming tomorrow. All right, anybody from Butte County? All right. Well, good. So that gives me how about those of you who work for municipalities, how many of you work in the planning department? Okay, in building? All right. It gives me a little better, all right, great. Gives me a little better understanding where we're going to be going with this. So we're going to be talking about this new requirement, and I'm going to actually cover the 3 W's in my talk today. The why are we doing this? Why is it required? And we're not going to go into a lot of in-depthness in that, but just to give you a general idea of why the city is having to do this. Then we're going to talk about the who. Who needs to comply with this? Who is applicable to these requirements? And then we'll cover the what. What needs to be done? And and we'll cover a little bit of the how in that as well. All right, so let's talk about some permit basics. And now I'm going to throw at you a lot of TLAs. And it wouldn't be a stormwater talk if I didn't do that. You know what a TLA is? No idea, huh? Well, there's going to be a lot of acronyms that you have no idea that I'm going to throw at you. TLA is 3-letter acronym. You got to have an acronym for everything. And so I'm going to throw some at you. And if I'm losing you with acronyms, and I have even been known to say a complete sentence in nothing but acronyms. If I do that to you, that means I had way too much caffeine and we need to slow this thing down. So just raise your hand. John, what in the world are you talking about? And we'll stop and define some acronyms. But what we'll try to do is define a few things up front. First off, the main reason you are here today, you can blame the federal government on that, it's the Clean Water Act. That's where all of this stems from. It's the Federal Clean Water Act. Now, it wouldn't be government unless they delegated downhill, and so it started with the feds, but it quickly got delegated to the states. And so the state of California took on or was given the permitting authority to issue these stormwater permits. And there's various permits out there. And part of the challenge too is some of you might be familiar with other stormwater permits, such as the construction general permit that's been out now in its new form for 5 years. And we use a lot of the same terminology: disturbed surfaces, impervious areas, so many acres, so many square feet. But they're completely different permits, and although it sounds the same, they're completely different requirements. There's other NPDES permits, which stands for National Pollutant Discharge Elimination System permits that come out of the Clean Water Act that affect industrial facilities. And there's one that affects municipalities. And that's the one where we're really interested in today, because that's where this is coming out of. So the federal government delegated responsibility for permitting stormwater permits to the state. The state then delegated some of this responsibility to the municipalities through what we call a Phase 2 MS4 permit. Well, there's an acronym for you, MS4. What does that stand for? It stands for Municipal Separate Stormwater Sewer System, an M and 4 S's behind it. Basically, it's just a municipal drainage system for stormwater. And so it's called Phase 2 because there was a Phase 1, large and medium-sized municipalities such as Sacramento had to come in under this originally, and they were given a very unique individual permit. So these larger municipalities have been living under these conditions for some time. So any of you developers or engineers who work with maybe projects in Sacramento or the Bay Area or in Los Angeles, what we're talking about today is probably not new information to you. You've seen this in larger municipalities. But now it's being passed down through the Phase 2 permitting cycle to these smaller municipalities. So cities like Chico and Butte County and Shasta County and Redding and Oroville and Central Valley actually has the majority of these Phase 2 cities now have to comply with this because they have a permit issued by the State Water Board called a Phase 2 MS4 permit. Now this permit became effective on July 1st, 2013, and as I mentioned, I got ahead of myself, but MS4 stands for, again, Municipal Separate Storm Sewer System. And it became effective July 1st, 2013, and it's a 5-year permit cycle. So each year we call a permit year, and the permit years are the stormwater year. So here in California, if we want to know how much rain we got this year, or maybe we should say how little rain we received this year, we'll look in the newspaper and it'll give a number, and that number will go back to July 1st. So if we look in the paper today, if they're doing it correctly, it should be measuring rainfall back to July 1st, which is nil to none here in the state. Hopefully with the El Nino year, what they're predicting, we'll see more in the future. But the same way in the regulatory world. When it comes to stormwater regulations, it's July 1 through June 30th. And so those are our permit years. Now, many of these requirements are new to these Phase 2 municipalities. And the state fortunately gave them some time to basically phase these things in, to ratchet up their program. And so they allow certain aspects of the program to begin during different years of the permit. And one of those requirements for year 2 was for municipalities to develop what they called a post-construction standards plan, which requires certain new developments and redevelopment projects to incorporate into their design a process called low impact development measures. And we'll talk more about this. What is that? And what did that involve? So the Phase 2 MS4 permit also, though, required some other things like adequate legal authority. The state realized that when they were delegating down authority from them to the municipalities to help implement a lot of these stormwater goals they had, they realized that the municipalities would need to develop their own legal authority to be able to enforce it. So one of their permit requirements was to adopt or revise new municipal code, new city ordinances that would require it. And it covered many different areas. One of the areas specifically that we're going to talk about today involves new development and redevelopment. But there were other areas that their ordinances had to address, such as during construction. So erosion and sediment control plans need to be implemented during construction, and there needs to be inspections, and And there's other areas involving illicit discharges. And, you've heard only rain down the drain. So the municipalities had to basically build this adequate legal authority to cover that. And the phase 2 MS4 permit required project owners and the municipality to continue to monitor these devices that are being installed to mitigate stormwater measures. And so a lot of times we use the term treatment, and we'll talk about this more later, but what is treatment? Well, in the context of this permit, treatment falls into several areas. One, infiltration, where we're infiltrating water into the ground. 2, bioretention, which is using like a rain garden, has some infiltration, but it also incorporates another aspect called evapotranspiration, where we're using either plants or solar heat to evaporate or transpire water into the atmosphere. And then the 4th is capture and reuse. A big topic during this drought about being a good steward of your water runoff and capturing that and reusing it if you can. Now, what do all 4 of those have in common? Those 4 areas of treatment? Really, what it does is it reduces the amount of discharge, does it not? Whether you're infiltrating, bioretaining, evapotranspiring, or capture and reusing, all of those have in common is that you have less discharge. And you're going to see that the focus of the stormwater goals and these permits has shifted. We've seen a paradigm shift in recent days, where it used to be we talked about putting in a grassy swale because it was so good, because it would filter out the pollutants and it would clean up the water, and it was all really quality based. Now when you look at these regulations, I think quality is still a concern and the ultimate goal, but now it's all about quantity reduction. How can we mitigate stormwater as close to the site as possible and minimize the amount of discharge? And thereby the thinking is, if we minimize the amount of discharge, we've improved the water quality as well. And so we're going to look at how that is done through concepts like low development or low impact development and hydromodification. All right. So the following are requirements according to the permit and according to the new ordinances that the municipalities had to revise and adopt. It requires projects to do these basic tasks. Now, we're going to come back to these tasks. We're going to look at these in depth in today's workshop. But here's just an overview. The first one is to take a project and basically divide it into logical segments when it comes to drainage. They call them drainage management areas. Some projects are diverse, and water is being dealt with in different ways in different places. And so in that case, the state wants it to be split up into what they call these DMAs, these drainage management areas. Other projects are quite simple. It really only has one basic way water is handled, and therefore it can have a single drainage management area. Again, we'll come back to this and talk about this in more detail. It requires including source controls for certain types of specific activities, and we'll see how that plays out. It requires the incorporation of LID measures into the design. There are 9 distinct measures that we will cover that the state requires. It requires treatment of stormwater, and as I mentioned, that's through these methods: infiltration, bioretention, evapotranspiration, and capture and reuse. It requires not only speccing out these treatment methods, but sizing them so that they meet the objectives specified in the permit. And then there's very specific numeric objectives given. And we're going to go through a couple calculators that you can use to meet that. And then it also incorporates in what we call hydromodification measures. Hydromodification is a big word, but if you break it down into just what it sounds like, hydro, water, modification, to modify, to change, the idea is that when you develop, you have hydromodification. Now, when I use that term, I use it in a neutral cause and effect way. In other words, I'm not here to say new development's bad, it changes the way water should drain off your site, therefore we want to avoid new development. No, when we use, and I believe when the state uses hydromodification, it says when you design, you can't help but modify the way water runs off. If you're creating impervious surfaces, you're changing the way it is. Therefore, let's understand that process and see if we can offset some of that by the way we design our project. And we'll go through that more in a moment. And then also, it requires not that you just do this in design and that you actually construct it, but this permit actually requires the municipality who is overseeing this program and the owner of the project to have a perpetual obligation to what's being installed. And there's no off-ramp, which is a little bit scary, but basically these systems need to be installed and according to the state need to be kept in an effective state of operation. And so there is a requirement to have an operation and maintenance plan. There's a requirement to have an annual self-certification by the owners of these devices. And there's an obligation for the city to make sure, or the county, to make sure that they are kept in an effective state of operation. Now, a couple of things too I want to say about this. The term post-construction, I don't like that term. To me, it's a complete misnomer because when I think post-construction, I think about what's after construction. And true, what is being proposed here, what is being built, is going to stay at the project after construction is done. And presumably that's where it got its name. But it's a huge misnomer, and I wish they would have called it something else because it really has everything to do with before construction. It's really all about design. It's all about engineering because that's where it begins. Now, I'm a consultant. I write a lot of SWIP plans, stormwater pollution prevention plans. Many times a contractor will call me up and say, hey, John, we need one of those SWIPy things. I'm like, okay, what do you mean? And what they mean is the whole enchilada, the plan, the monitoring, everything involved. And so we'll get to work on the construction general permit, develop their erosion sediment control plan, and come up with their program. But under the construction general permit, they actually have a tie-in to this, as many of you may know, to post-construction requirements if you're outside of a municipality. And so we'll get to that point and say, all right, how are you going to meet these post-construction design standards? And, they're tapping their foot and they're like, I need to SWIP by next week. We're starting construction next week. And I'm going, have you done anything at the site to plan for infiltration, bioretention, evapotranspiration, or capture reuse? And they're looking at me like I'm crazy. And here, they're wanting to start a project, and I'm saying, guess what? We need to go back to the drawing board because it has everything to do with design. It starts with engineering and good site design and good site planning. And so that's why it's so important for the municipalities to get the word out through their planning departments and their building departments that these concepts need to be understood early on in the project and need to be built into the design. Actually, one of the calculators we're going to look at, and it's going to be for the small category of projects, is from the construction general permit. And so there is some crossover in some of these permits. So now that's the why. Bottom line is, it's a federal requirement delegated to the states and delegated from the state to the municipalities. And we might not like it, but we're stuck with it. So who now needs to comply with this? Who is applicable to this? Well, when you look at this, you're going to see that there are 3 basic levels of applicability. 3 basic. And we'll start at the bottom rung. There are going to be projects that are not applicable. They're going to be, in general, less than 2,500 square feet of new or replaced impervious surface. You know what impervious is, right? Speaking to a crowd that probably understands that. It's hardscape, basically. Anything that cannot infiltrate stormwater. So we're talking roofs, sidewalks, parking lots. So if it's creating or replacing less than 2,500 square feet, you are most likely going to be not applicable. Of course, like with any regulation, there are some exceptions, and for time's sake, we're not going to delve into that at this point. Next level are called small projects according to this permit. And they are projects that are creating or replacing 2,500 square feet to 5,000 square feet of hardscape. And then the top tier are the regulated projects. Not that small projects aren't regulated, they are. That's just what they call them. The top level is called regulated, and that's 5,000 square feet or more. Let's take a closer look at the small and regulated projects. So small projects specifically, as I mentioned, includes new construction that's creating impervious surfaces between 2,500 square feet and 5,000 square feet. So if it's a new project and it's creating that, could be a new parking lot, could be a new school. We'll look at some examples. We're actually going to look at a very specific example later. It could also be redevelopment. It could be a demolition of another small site and redeveloping that site. And if you are even replacing a hardscape or impervious surfaces of 2,500 to 5,000 square feet, then you would be a small project, such as the replacement of even a parking lot between 2,500 and 5,000 square feet. Now, small projects also include the construction of a new project that's less than 5,000 square feet. Now, catch that subtle difference. One was redeveloping a parking lot, basically replacing a parking lot. One was a new parking lot. Now, some of you who are more educated in this should be thinking about, what about routine maintenance? I thought resurfacing a parking lot doesn't trigger these requirements. Well, you're partially correct. It keeps you out of the regulated class, but it still kicks you into that small class. Now, before you start hyperventilating, this small class is not really a big deal, so it'll be probably okay. You're not going to really have a hard time meeting this. Other small projects, according to the permit, is a roadway or sidewalk project that is creating or replacing between 2,500 and 5,000 square feet of impervious surface. It also includes, here's another acronym for you, LUPs. You may recognize that from the construction general permit. But linear utility projects, what are they? Well, they could be underground projects like a water main project, a sewer line project. It could be a above ground utility like a PG&E transmission line. They are not considered to be part of small projects. We'll see another reference to this later. And a single family home is not, or is a small project, will always be a small project, even if it's a really big single family home, bigger than 5,000 square feet. Even if it's a lot more, it will always be a small project. Now, unless it's part of a larger common plan. And we're going to look at some examples today of that. Once it is part of a subdivision, it would then very likely be regulated. Okay, now let's turn the corner and look at regulated projects. What are regulated projects? Well, as we saw on the first slide, it's creating more than 5,000 square feet of impervious surface. And it can also be what's called significant redevelopment. So it's where you have maybe a demolition of a site and the redevelopment, the replacement of impervious surface, that's 5,000 square feet or more. Or it could be replacement or creation in a redevelopment project. The replacement of more than 5,000 square feet of a parking lot would also be a regulated project. But let's look at some things that regulated projects do not include according to the permit. And it's probably an easier way to define regulated projects by looking at what's exempt. And so these are real important to take a look at. As I mentioned just a moment ago, a single family home, detached, that's not a part of a larger common development or common plan, they are considered to be a small project. It doesn't matter how much square feet of impervious surface they have or are replacing, it is a small, or will always be a small project. Projects that are exclusively interior remodels, if nothing's changing outside, it could even be a huge warehouse. If it's exclusively interior, it is not a regulated project. Routine maintenance or repair, such as an exterior wall surface replacement. Now, if that could be categorized as routine maintenance, then possibly you have your exemption there. But if it's a facade replacement that's not considered routine maintenance, and that's really who's going to make the decision on that, it's really going to be the municipal's plan check process. They're going to make the call. They're the ones interpreting this regulation, and they're going to look at their post-construction standards plan, make that call. Pavement grinding and resurfacing within the existing footprint is also routine, and roofing replacement or repair is also routine. But we did a project here, I think it had to be it was early this week or late last week. We're looking at a concrete or sidewalk replacement, and we could not fit that under routine maintenance. However, on that same project, they were doing a parking lot resurfacing, and that clearly was routine maintenance. So the municipality we were working with would not accept that our sidewalk was routine maintenance. Other things that are not included would be projects consisting solely of sidewalks or bicycle lanes built as a part of new streets or roads and built to direct stormwater runoff to adjacent vegetative areas. And this is language right out of the permit. Projects consisting solely of impervious trails built to direct stormwater to adjacent non-erodible permeable areas. Again, it's kind of meeting already the intent of it, and maybe that's why they're exempting it. Projects consisting solely of sidewalks, bicycle lanes, or trails constructed with permeable surfaces. Is DG, decomposed granite, a permeable surface? Good question. Technically, yes. Functionally, probably not. But technically, it would be considered a permeable surface. All right, and other projects that would not be considered regulated would be a replacement of damaged pavement. And I think this may have been one of the questions we were getting at too. Replacement of damaged pavement or replacement of short, non-contiguous sections of roadways. So roadway repair, sidewalk repair, because the roots are pushing up sidewalks. That would not be a regulated project. Now, please remember though, it could still be a small project. We're just talking about what's not a regulated project. and trenching, excavation, and resurfacing associated with those LUPs, those linear utility projects, unless it has a discrete location that has 5,000 square feet or more of newly constructed contiguous impervious surface areas. What are we talking about? It would be like maybe we're putting, pipeline companies putting in a pipeline, and then they have these breakout stations or these pumping stations or these control stations where they have a parking lot, maybe they have a small office building. And so that would be a type of project that, although it is LUP, it is a discrete area that could be considered a regulated project. All right. Now, there's also something in the regulation called the 50% rule, or actually, it's not called the 50% rule in the regulation. I call it that, but this is the idea. It basically says that if you're increasing the impervious surface of the project by less than 50%, so you're replacing impervious surface, but it's less than 50% of the project's existing impervious surface, then only the new redevelopment portion must be treated. Conversely, if it's more than 50%, oops, went too far. Go back. If it's more than 50%, then the entire project has to be treated. And so that's a number to look at. Now, some of you may actually also do like capital improvement projects. That's something important to remember there. Roadway projects, you want to look at that number. And there's some specific language in the permit and also in the post-construction plan that deals with roadway projects in regards to this 50% rule. But in general, if it's less than 50%, you're only dealing with that. If it's more than 50%, you're treating the entire project, the entire site. So we covered the why. We covered who needs to be covered or subject to this. Now let's talk about the what. What is required? And this is where we're going to get more into the nuts and bolts now of how this works. Now, let's see. So there's some steps for implementing this post-construction standards plan that I want to cover. First off is get a copy of the actual document, the post-construction plan, the calculators, and the worksheets. Determine the project's applicability. Designate those DMAs. I'm just going to list these out, then we're going to go through each one of these. Identify appropriate source controls. Incorporate the LID measures. Select and size those treatment controls. Incorporate hydromodification measures, and then prepare the submittal. And we're going to go through each one of these one by one. So let's take a look at the first one. And you need to get a copy of the plan, which, if you are in the City of Chico, good news is you had one. As I don't have one right here in front of me, but it looks like the one on the screen. You got a copy of their draft plan that they are quickly on the way to revising. And actually, these series of workshops is part of their process of finalizing these plans. This is part of their outreach to the community, to the stakeholders who are going to be having to work under this to get a view of how this process works and for you to be able to review the draft plan. Now, if you have any questions, you can contact Angela Spain. Angela, raise your hand. Or Rich Burgee, right behind her. And Rich, how can they get a hold of you if they have questions or comments? Or Angela, who's primary contact?
We'll have some business cards on the table.
Okay, so there'll be some business cards back there. And so as you go through this document, take a look at that. But basically, this is what's going to be required of new development and significant redevelopment. Now, one of the reasons why I was asked to come do this presentation is because I'm actually the author of that document. So you can all throw tomatoes. and make sure you kick me on the way out the door. But let me tell you a little bit about our approach first in developing this document. First off, I am what I consider to be a minimalist when it comes to regulatory compliance. And by that, what I mean is compliant and no more. So that's really big to me, because there's enough of a regulatory burden on business, on Californians, where, you know, we understand the importance of complying, but we definitely don't want to go beyond that and increase the burden of those having to develop in these municipalities. And so when we wrote this plan, we stuck strictly to the State Water Board's permit that the City of Chico and the other small municipalities have to live under. And pretty much what you see in this plan, you can almost find verbatim in the permit. Now, there are only a couple places where we changed. And I'll tell you, actually, there's only one main place where we changed. And first off, it's in the submittal requirement. What we required is that those submitting the plans for these post-construction measures be licensed professionals. Now, that wasn't in the permit, but we thought that rather than make the city or the counties, the municipalities develop their own standards and say, this is the way you are to do a bioretention cell. This is the way you are to do a grassy swale. What we wanted to do was basically leave it up to the professional community. So civil engineers, landscape architects, state licensed professional individuals are going to put their stamp on these plans and say, we designed this, and basically just as any other development would be done, or plans that are being proposed to the city. That is frankly not the way it's being done all across the state, but it's the way we thought made the most sense. The other thing that allows is for a better mousetrap to be built. If one of you come up with a more ingenious way to do these infiltration or bioretention measures, then we're given that ability to do that. As long as you put your PE there, your landscape architect license there, then it's going to be accepted. And of course it has to comply with this plan, but this plan basically is just the regulatory requirements. So that's the one place where we went beyond the permit, and really it was just to put the onus where it needed to be, is on the professional. So you need to get a copy of these plans. Now, if you're outside of the City of Chico, Oroville, I know I've been talking with your city recently about joining this. Oh, and what I should also say is this was developed as part of a collaboration. There were actually, I think now, 23 Central Valley municipalities working under this same document. And one of the reasons why we wanted to collaborate is because before that, sometimes when you went from across the street from a city to unincorporated county, you could have a completely different experience, completely different requirements. And so what we've been trying hard, many of the municipalities saw a need to have a standardized plan. So we developed a plan that is standardized. It's a template. Each municipality can customize it as they see fit, but by and large, it stays pretty much the same as what we've been seeing. And the other benefit is we've been doing collaborative trainings on this, where all the municipalities have been sending their plan checkers to a combined training session to learn how to implement this plan. So that's the plan, and right now it's in draft with the City of Chico, and you have a copy of that, and we're actually going to be going through that. Also, as a appendix of that plan or attachment of the plan is a worksheet that you also received coming in. It should look like this. And this is what we're actually going to be going through on the rest of this segment, the rest of this talk. So we got about, let's see, it's about 1:45 right now. We have about an hour and 15 minutes that we're going to spend going through the nuts and bolts of how this works. Another thing that you need to do is get a copy not only of the plan but also the calculators. I'm going to give you your first view here of the calculator and for small projects, but then we're going to actually take a project and look at it as if it was small and run through the calculator. Then we're going to take another project and look at it as if it's a large project and run through the regulated calculator. So these are Excel spreadsheets. This calculator you see on the screen will be downloadable from the each municipality. The one you see on the screen actually came from the State Water Resources Board and was originally used as part of the construction general permit. Those of you who write SWIP plans for construction sites probably recognize this. And now it's actually on the State Water Board's SMARTS database website. But this calculator was developed by the Water Board for small projects operating under this Phase 2 MS4 permit. And again, we'll come back to that. This calculator that you see right here is a volumetric sizing tool that we created as a part of this collaborative effort to make the sizing of the BMPs easier. And we'll go through it. We'll show you, we actually used the 2 approved methods for sizing BMPs. You're given an option as a developer which method to use. We've noticed that sometimes one method is more advantageous than the other. And so we wanted to give you the ability to choose whichever was more advantageous for your particular project. This also is an Excel spreadsheet that you'll be able to obtain. The next item is to determine your project's applicability. Your project's applicability. Now, for the remainder of this talk, we're going to take a look at a fairly typical project. This is actually a real project, not here in Chico. It actually is a project that I worked on in Benicia. Now, Benicia is part of the Bay Area. Their regional stormwater permit, and they call that the C3. Those of you who have done development in the Bay Area know it by C3. That's their post-construction standards program. And that's been in place for quite some time now. And so, but there's a lot of similarities, some subtle differences, but a lot of similarities. So this is a real project that went through these post-construction standards and treatment. So a small project, an example of a small project would be, we're looking at a plan here of 4 new parcels, but let's say only one of those parcels was actually going to be built. The rest, they aren't building, not going to ever build, but right now it's only going to be one project, one house, or maybe it's one house period. That is, as we saw earlier, a small project. Doesn't matter, could be 6,000 square feet, could be 20,000 square feet. It doesn't matter how many square feet of new or replaced impervious. If it's a single family home, not a part of a larger common plan, it is a small project. Now, though, if we had all 4 of those lots being developed, which was the case, the actual case of this project, they had on the right-hand side, they had a small existing home that I think they were going to greatly renovate and then add 3 new homes to the, it would be to the west, basically. Then that would be a regulated project. Well, why? Well, it's no longer a single family home, and it is certainly over 5,000 square feet of new impervious surface. So that would be a regulated project. Now, what about this scenario? And we see this a lot. 2 different homes being developed, especially in these post-recession times. Well, some people say we're still in the recession, but hopefully we're getting out. We see unfinished lots that are now starting to be developed upon. What if we had 2 of them being built on? What if we had 2 different contractors building on them? maybe two different owners. Would it be two small projects or one regulated project? What do you think? How about some participation?
Two separate owners, it would have to be two small projects.
Two small projects?
Although was the land split and the four parcels from one person?
You're asking the right questions. It's really going to depend, really ultimately on the map approval. Is it still under a valid tentative map? Is it still if the map is expired? And I'm talking to planners. You guys know your business way better than I know it. But if it still could be considered a common plan, part of a common development plan, and it still has a valid map, then yeah, it probably could be considered part of a common plan.
Is there a lot size max in there for that? Still count? Those are not.
Not in this regulation. There's not. The only thing we looked at is things we've already seen, the 5,000 square feet or the 2,500 square feet. But in this case, we would be looking at if you had two projects even being built by two different individuals, but it was part of the same approved plan, then it very well could be considered regulated. Now it gets really muddy really quick. Where do I see this played out at is really at the plan check process. Your planning department is going to have to make a call. Is it part of a larger common plan, or has that expired? Could they consider it not a part of a common plan? Why are they going to be the referee? Because it's their municipal permit. And what will happen is that the State Water Board and sometimes the US EPA will come in and audit their program. And they're going to ask for all the development records, and they're going to ask, how did you condition these projects? What was not applicable? What was small and what was regulated and why? And so if they have this situation, then they're going to have some sort of justification to say, this is why we consider them too smalls. Or this is why we had to consider them as one regulated project. Okay, so let's move on. Designate drainage management areas, DMAs. And we talked about this already briefly, but in a project like the one we have here as an example, a 4-parcel development, basically we're going to break that down into 4 different DMAs. Now again, this was an actual project. Why they started numbering right to left, I don't know. But I wanted to stay consistent with these actual plans. And here you can see a blow up of DMA 1, which is parcel 1. And you can see that it is just a single family home, and they're using bioswales as their treatment measure. DMA 2, the second home, again a bioswale. DMA 3, kind of a 2-part bioswale. And then what is a bioswale? A bioswale is goes under different names, rain garden. Basically, it is a bit of a detention center where it's combining 2 of the aspects: infiltration, it's giving a place for water to infiltrate into the ground, and also using the evapotranspiration effects where the plant uptake. So typically a bioswale would be a depressed landscaped area that has been engineered. So usually there's as much or more below ground than you see above ground. For example, you have some engineered soils, and you'll see a speck at the as we get towards the end of our talk that's got to be 18 inches of growing media. You're going to have usually a rock layer for reservoir capacity. You typically have an under drain that will allow excess water to flow off site to maybe the storm drainage system or some other place, maybe a retention basin or some other destination. So it's allowing water to flow to it, to infiltrate, to evapotranspire, and hopefully with the idea to reduce the amount of discharge. And so those would be our 4 DMAs. In this case, a fairly logical sequence because each particular home site is going to be treated separately with a bioswale there. Now, could you have a different configuration? Yes, it will all depend on what treatment you select. And there are even times where maybe a regional treatment is being done. In other words, we're going to channel water from all 4 of those sites to maybe one big retention basin or one big bioretention cell. Or maybe it's a retention basin that's serving that whole neighborhood that's been sized to do that. Now, again, we need to be careful when we look at these regional things because many Central Valley municipalities have retention basins as a part of their flood control system. And especially Lodi South, we use a lot of retention basins and maybe rock wells to dissipate the water. And could those be considered a regional? Yes, but it gets really difficult because you have to have the engineering and the calculations behind it to show that you have sized it not only to accommodate this development, but also all previous development and all future development. So usually like a large municipal retention basin, even with no outlet, many times cannot be proven to meet these requirements. However, I have seen maybe a retention basin that is part of a planned community that has been sized specifically to handle all of the development and future development of that can meet it. So you'll want to look at that. Next, though, is identify appropriate source controls. So just backing up a little bit because of the break and all, we got our plan, we got our calculators, we determine our project applicability, whether we're small or regulated. Once we determine we're regulated, we're going to divide this up into DMAs, drainage management areas. Now, each DMA is going to have to go through the process, the next 5 points. Source controls. We're going to have to look at source control for each DMA. What do we mean by source control? Well, for a housing or for a home development, maybe none of these or few of these would apply, especially our example. On the screen you can see, or maybe better in your notes, you can see the table that comes right out of the document that Rich handed you at the door. And you can see the source controls that are identified. These come out of the permit. This is a list of activities or pollutant sources that might be present or associated with a certain project. So for example, they say accidental spills or leaks, interior floor drains. Well, you might say, I don't have any interior floor drains. And what we mean by that is an interior floor drain that ties into the storm drainage system, not into the sanitary sewer. Parking or storage areas and maintenance, indoor or structural pest control, pools. Now, residential could have pools, spas, ponds, decorative fountains. But some of these are very specific, like restaurants, grocery stores, fueling facilities. And again, what you would want to look at is the definition for each one of these, what's included in it, what's not included in it. Now, one of the things that's always bugged me about this is that some of these are really more activity than they are design, like the first one, accidental spills and leaks. Remember what we're talking about. We're talking about designing a project. How do we design for accidental spills or leaks? Well, the permit says that you have to take into consideration the California Stormwater Quality Association's guidance on these activities. CASCA is the acronym, California Stormwater Quality Association's guidance. And in the document that we created for the City of Chico, we have all of these hyperlinked to what is basically a fact sheet on these activities. And so for like accidental spills or leaks, it would talk about that if you have substances that could spill or leak, then you need to have appropriate spill prevention measures, maybe a spill kit, maybe isolation valves, especially if you're a chemical plant or industrial facility, a way to isolate the spill source from the storm drainage system. And so for each one of these, there's guidance given. And so your requirement as a developer or a project proponent is to look at your project and more specifically, look at each DMA for that project and say, do we have any of these activities or features going on in this portion of the DMA? You got a fueling facility in that portion? Then yeah, you're going to have that. Oh, it's an apartment complex. You have an outdoor garbage disposal area, trash disposal area. Then yes, you're going to be in there. Now, if you read that fact sheet, you'll notice that it doesn't apply to single-family homes. So you'll want to take a look at each one of these activities and apply their guidance as it applies to your project. Next is incorporate the LID measures. In the permit, they list 9 different measures. Now, this is going to be the most challenging portion of this regulation. I guarantee it. It's going to be very challenging. So let's go through these 9 and talk a little bit about it. Now, I think there are going to be some projects that it's not a big deal. It's not a big deal. Maybe even this example project, not a real big deal. There's going to be other projects, it's going to be a huge deal. It's going to be very expensive, challenging, and maybe even almost impossible to meet. The City of Chico didn't write these. WGR didn't write these. These come right out of the permit. So, first one, define the development envelope and protected areas, identifying areas that are most suitable for development and areas that are to be left undisturbed. And so what I want to do is rotate this a little bit and show you the actual aerial photograph. This is the actual pre-development photograph for our example project. Again, you can see down at the bottom right corner, I don't have a laser pointer, which I usually have, but down at the bottom right corner, you can see an existing house that's going to be either demolished or renovated. And on that lot, within that blue line, that blue rectangle, is going to be the 4 houses. So the development envelope's pretty much set. There's not much room to protect. We'll talk about trees here in a moment, but it's not like we have a stream passing through it or adjacent to the project. It's not like we have an area that's more a wetland area of this project. Now, a large commercial development, a really large project could have areas that, okay, we want to look at this. How are we developing it? What areas are most suitable for development and areas that should be left undisturbed? We're going to get, though, more into that here with the next points. The next one is to concentrate development on portions of the site with less permeable soils and preserve areas that can promote infiltration. So, what does that mean? Well, that means that if your site has multiple soil types and they're different, let's say you understand what hydrologic soil group is, HSG classifications, they're A through D. So A is the most infiltrative soils, D is the less infiltrative soils, the least infiltrative soils. If you had one section of the site that was A and one section that was D, according to the state, where do they want you developing? D, right? What if the developer wants to develop on A? It's going to be a problem. Let them. Well, yeah, you could let them, but you're going to have a hard time if you get audited by the EPA or the Water Board to say why you let him. Because they're going to want to look at the rationale of how they met the LID measures. And so, in our case, I went to the web soil survey, actual site, I did my boundary with those blue lines, And on the web soil survey, it all came up as a single soil type. So I was fortunate. I didn't have this quandary to figure out where to develop this site. It's all one single soil type. So it really was not a big deal in this case. But I can see projects where it's going to be a big deal. But again, the municipality didn't write this requirement. This is being required by the State Water Board, and they consider this an extension of the Clean Water Act. Could you get in trouble if they found you developed contrary to this? Yeah, big time trouble. Yes, sir.
Are we supposed to require the owner to take a drill rig out the site, use soil boring, and characterize the soil?
Well, yeah, and that's not unusual because actually this site did that. Most sites have a soils report.
Well, would be unusual for a single home.
Single home would not be a regulated project. Right now, we're only talking about regulated projects. Okay, so no, it's really not uncommon. And the web soil survey, something like this, would suffice meeting this LID requirement. I mean, if it is all one single soil type according to the web soil survey, I'd stop right there. That's my proof. Now, I also want to acknowledge that I believe this will be the most heated discussion you'll ever have in all of these requirements.
Aren't you kind of illustrating a single project though, with a single owner?
No, there's four.
Oh,
There's 4 homes being built here. So, third of 9 requirements under LID measures is limit overall impervious coverage of the site with paving and roofs. That's what it says, limit. Now, again, they don't define these things, and we really struggled with how to demonstrate that these 9 LID measures were met. And what we ended up doing after really consulting with various municipalities was this worksheet you have here is what the developer's going to submit. We have 9 boxes where they're going to give a narrative explanation of how they met that. How did they limit it? And we're really leaving it up to them to show us how they did that. Now, as long as there's some rationale behind it, some logic behind it, showing that they did limit the overall, if I was a plan checker, I would accept it. I got my base covered in meeting that I required that they show how they limited it. I have the documentation to show they limited it. So, if the site is completely paved, which it wouldn't be, then we probably need to talk. But there's a lot of green on this. Yes, sir.
You think, well, for example, the placement of the building in relationship to common driveway may be required?
I think you can. What worries me, and again, I didn't write this regulation. This is me going to the other side of the fence going, what if we get a plan checker, none of you, I'm sure, but some of them get rather gung-ho. And I could see a municipality where, they're really riding this developer, trying to whittle it down and whittle it down and whittle it down. I don't know if that's what's required here or needed here. I think as long as they can show some rationale that, yeah, we considered it, our objective is to build 3,500 square foot homes. That's our objective. And we need a driveway. No, we're not going to drive up on the grass. We need a driveway. And the city ordinance says you got to have it. And, as long as they can show the rationale that for the development they're developing, this is limited, then I would let them have it. What I'm worried about is with the language that the state's requiring here is that we'll see abuses. But again, I didn't write it. We're trying to be true to our minimalist approach and only present here what the state's requiring. So unfortunately, we got to live with it. And the best way we could come up with without overtaxing the developers is to just give them a box and say, you tell us. And as long as it sounds logical and there's reason to it, then good for you, we'll put a check mark next to it.
So we're trying to limit the stormwater runoff from the site. Correct?
Well, only taking this at face value here, all we're limiting is overall impervious coverage.
Okay. So we've got a site that's clay, adobe, or a non-pervious site to begin, and we put development on the site.
Yeah, but remember my tongue-in-cheek joke is DG is clay. This site's clay. I mean, this site, we looked at it, is actually, I don't know if you could see the soils report when we looked at it, it's clay. It's hydrologic D. It's probably not going to infiltrate a whole lot unless you engineer those bioretention cells.
So to develop that site, you still are going to have to show that you're dealing with the runoff, even though.
Well, let's just take it bite by bite. Right now, all we're talking about is number 3 LID objective by the state is show to us how you're limiting the overall impervious coverage. And so what we have developed, and this is based on input from other municipalities, is just have the developer tell us, how are you doing this? As long as it's logical, makes sense, we're going to accept that because we need something to back us up that we asked a question.
It would be as simple as saying, we incorporated the lot coverage standards in the zoning ordinance of the city.
Yeah, I think so.
Could this be, what they encourage large lots?
I'm sorry, go ahead.
Is it saying that also the state saying maybe we're encouraging the large lots instead of smaller lots? We got the coverage there?
I'm afraid to say what the state is saying. I try to, sometimes I try to just take, sometimes I try not to read too much into it and I try to take it at face value
Okay.
because it's a slippery slope. Yes, sir, in the front. You had a question?
Well, I'll let
Okay. Okay, let's go to 4. Setback development from creeks, wetlands, and riparian habitats. Well, for this particular project, not an issue. Now, is it ever going to be an issue? Is this the first time they're dealing with this type of stuff? No, there's a lot of other regulations and ordinances that already require that, so it shouldn't be a big deal. It really should not. So number 4, I don't think it's going to be a real issue. One, you won't get projects that often with this. And the other thing is, even when you do, there's other regulations already requiring this. So it won't be a big deal. Preserve its significant trees. Chances are you already have ordinances in place that require that to a certain extent. So again, probably not a huge deal here. But in this case, and I have the plan here, most of those scraggly little trees are being pulled out, were being pulled out to make room for the houses they are putting in place. But the landscape drawing, and I didn't show that here, is putting trees back in. Again, we're giving a narrative box to show how they're going to address that. Conform to site layout along natural landforms. And I show here the plan and the side view. Now, one of the things that they did do with these bioswales, and they had to do it for functional reasons, is they had to terrace some of these so that they would actually work and flow and be able to retain the amount of water. So in just doing that, yes, they've demonstrated they've conformed the site layout along natural landforms. 7, avoid excessive grading and disturbance of vegetation and soils. Well, the entire site has to be developed in this case. And again, I look at keywords, avoid. We can't avoid it, it's unavoidable. It's the project by definition is defining, is grading out the whole thing. But then if they came back and said, you know, however, we're going to landscape this entire thing, to me that meets the intent of it. As long as they've described how they're doing this, then I would accept that. 8, replicate the site's natural drainage patterns, kind of similar to number 6, I think it was, that we saw. And if you look at the topos here and where the placement of the bioswales, fairly close. And then 9, detain and retain runoff throughout the site. Well, with the use of the bioretention cells, yeah, they're definitely detaining and retaining runoff throughout the sites. Each module, each model, I should say, has that. All right, so those were the 9 LAID measures. And if you look at your worksheet here, we have a place where the developer the project proponent is going to explain how they're meeting each one of those. The next one, select and size treatment control measures. Select and size treatment control measures. Now, the first thing is selecting. And we talked about these treatment control measures are not what many times you might think is treatment, like activated carbon, or reverse osmosis or some sort of treatment. When we talk about treatment, we're again talking about infiltration, bioretention, evapotranspiration, or capture and reuse. And so there's a table given in that document that was handed to you that has different types of measures here. Things like stream setbacks and vegetative buffers, if you have that type of situation. Soil quality improvement, engineered soils is what it's about. Tree planting and preservation, porous pavement. Go to the next. Green roofs, vegetated swales, which, by the way, is different than bioretention swales or what we have on this project. Without getting too far into it, vegetated swales is more of a flow-through type of a device, and so our sizing criteria is going to be flow, where bioretention is going to be volume. Rain harvesting and reuse, and then in the kind of the brownish color there, you see the one was selected for this project, bioretention and rain gardens. Then you have other things like infiltration trenches, flow-through planters, tree wells, retention and detention basins. And some of these are broad enough that they can accommodate other specific types of devices that infiltrate, bioretain, evapotranspire, or capture, reuse. So you'll select it, and then you will size it. Now, first off, let's take a small project. I know we were talking about a regulated project, but just so we can show the calculator for a small project and how it works, let's assume it's only one of those houses being built. So it's a small project. It's this one that you see on the screen. So what you'll do is open up the Excel spreadsheet for it's called the Post-Construction Water Balance Calculator. This calculator was developed by the State Water Board. And let's see, I know you can't see that on the screen. I'll try to zoom in a little bit here. The best way to is just to play with this yourself a little bit. So it's got some steps. The first step is to show where your project is located. And let me make sure I'm here. So, all right. So you select through pull down cells where your project's located. So in this case, let's say it's in Chico. It's Butte County. So that's already selected. And then you come down and it gives some options for weather stations. Now, some counties, there'll be only one weather station that you can choose from. In Butte County, they give us 3. And you may need to know a little bit about the local area and where your project's at to determine which would be the best. But you're going to want to pick the weather station closest to your project. One's Brush Creek RS, Chico University Farm, Oroville RS, and Sterling City RS. Unfortunately, they don't give a lot of definition in this tool, so you're going to need to figure out which one best fits. Chico, our project's in Chico, that's probably going to be Chico University Farm. So we pick that one. Moving down on our thing, on our spreadsheet here, we then have to show what type of soil type we're dealing with. Well, according to the Web Soil Survey, that site was all hydrologic soil type D, least infiltrated, was clay. And so you select by pull down menu the A, B, or C soil, A, B, C, D, or D soils. And so I pick D. And then the next step is indicate the existing dominant non-built land use type. Again, existing dominant non-built land use type. So right now, what did the site look like before development? Well, we had a home, a small home, but the non-built area looked like pretty much open space with some trees. Now, you're not given a lot of choices, but I know you won't be able to read this, but your choices are basically open space, grass cover 50 to 75%, grass cover greater than 75%. Then it's like natural desert, cultivated agriculture, grasslands, what else we got? Meadow, pasture, brush. None of the others were even a close fit. So we pick open space, grass cover 50 to 75%. Step 4, indicate the proposed dominant non-built land use type. So what's going to be proposed? Well, we got a homes, or in this case, it's a small project, one home, a driveway, but non-built areas, landscape, right? It's going to be landscaped. And if we look at our options, the best option in that list is a mix of lawn, grass, pasture, and trees covering more than 75% of the open space.
That's not drought resistant.
No, that's not very drought resistant.
Okay, well, you're probably right. We could pick brush or chaparral covering less than 50% of the open space. They're going with xeriscape. Whatever they end up going with, you want to figure out and just match it to what they're going with. I'm assuming it's El Nino year and we're out of the drought.
This is one line of,
Hopefully.
it's covering more than 75% of the open space, then after roof structures and driveway and all that space.
This is of the what it says non-built land areas. Yeah. All right. So yeah. All right, and then we enter in some information about the project, the total project size. That lot was a 7,500 square foot lot. Sub-watershed area means if you're dividing it up into multiple areas, in this case it's just one small site, so the whole sub-watershed is 7,500 feet. In other words, we're looking at 100% of the project. Now, after we have set that into place, notice here, those of you who understand runoff curve numbers, what happened. The existing runoff curve number was 87 based on the type of land, non-built land use type. The proposed runoff curve number is the same. Now, if we were under the construction general permit, we wouldn't have to do anything more. We had met it. As long as our curve number is equal or less, then we've met it. But in this case, under this permit, we're required, small projects are required to quantify, use one of the treatment controls. Coming down here to step 7, we need to show existing rooftop and existing non-rooftop impervious coverage. Now I assume there's a small house there, a bit of a driveway, pretty small development. I use 1,500 to 250 square feet. Proposed new, expanded home or new home, 2,100 square feet and 839 square feet of driveway and sidewalks and that type of thing. And then the last step to meet this would be to pick one of your treatment controls. Now they only require one to meet this small requirement submittal. And so I actually spec 2 in here, but you would only need to do 1. I did impervious area disconnection, meaning that we were going to have a bioswale. We're going to channel all the water from that home to a bioswale. Which one, though, do you think they'll pick 99.9% of the time on that list? Exactly. Tree planting. Why? Because the ordinance already requires it. You've got to have a trees. And by planting the trees, they've met it. For the small project, this is the calculator they have to use. They have to pick one of those credits. They have to quantify it. But guess what? This permit does not have any objective that they have to meet. They don't have to offset it by a certain amount. They don't have to reduce their discharge by so much for a small project. Just pick one, quantify it, print this out, submit it to the plan checker with your worksheet. That's all a small project needs to do. Okay? Now, that's a small project. A large project, though, is a little bit different. So if we are a large project where we have all 4 of those lots, now let's just take that first lot, the same lot that we had for the small project, but remember there's 3 other lots now, a part of our regulated project. But for each DMA, our first parcel being 1 DMA, we now need to quantify our discharge, or quantify our how big our BMP is going to be. So let me go back here, and we use this calculator that will be provided to you with this plan. And let me scroll out here a little bit, just so I can navigate a little easier. So you'll put the DMA's name at the top of this, and then under step 1, you'll enter the square footage for that DMA. In this case, parcel number 1. Same one we looked at on the other tool, 7,500 square feet. Step 2 is you're going to need to enter the total percentage of impervious area in the DMA. The total percentage of impervious area in the DMA. Well, it's just a calculation. And so it's the amount of impervious area over 7,500 square feet. In this case, it works out, proposed impervious area, I should say, works out to be almost 39.2%. Now, what are we doing here? There's actually 2 calculations working in the background here, because the permit says that the developer has their choice of methods of how to size their BMPs. And we have noticed that sometimes one method will have an advantage for the developer over the other. So we said, why don't we build a calculator that'll do them both, and then at the bottom, the developer can decide which one's more advantageous for them. And so if I scroll over here to the right, you'll see in the gray some numbers working in the background that are based solely off the percentage of impervious area. Solely off that. If you want more detail, we provide it in the document, and we also provide a video that goes more in depth on how this works. Now, the next is we need to take some of the credits for this, and one of them is trees. We can plant trees, and trees will give us a certain amount of offset for this. Now, where do we get these numbers? Basically, we're replicating the credit that was on the state's calculator. Where did the state get the numbers? I don't know. They don't say. They don't give any backup for that calculator. So all we're doing is taking their numbers and using exactly the numbers they used. I'm being a little facetious there, but they don't have any footnotes. They don't say this is the manual we're pulling it out of. Yeah, it's really not good. So we enter the number of evergreen trees, number of deciduous trees. Each one gets a certain amount of credit. If we assume for those 4 lots, we're going to have 12 evergreens, maybe 3 on each lot, and 2 deciduous trees on each lot. That will give us not a lot of credit, but a little, and we'll take it. Next step is now we need to determine, just as the other calculator, how much rainfall we get. The state, the method that the state requires says you're going to use local rainfall data. And what we have noticed is that it's fairly linear between Fresno in the south being the lowest amount and Redding in the north being the highest. Now, for the interest of time, we're not going to get into that with this, but I give some other worksheets on here that show the maps, show how it's linear, show the relationships. And so to make it easy for the developer was we just say, are you north or south of Sacramento? And if so, as a crow flies, how far north or south? What if you're immediately east of Sacramento? Then you'd be 0. What if you're immediately west of Sacramento? Then you'd be 0. But as you go up and down the valley from Sacramento, roughly how far are you? So Chico, if we were doing this project in Chico, roughly 85 miles. And so I enter north of Sacramento, 85. And what that does is it gives you an average runoff coefficient for the DMA of 0.4. I'm sorry. No, I'm sorry, I skipped a step. It gives you the DMA's unit basin storage volume is 0.32. I skipped a step. Specify the composite average runoff coefficient for the DMA. There's one other step that needed to happen. And that's your runoff coefficient. Now for the DMA, we do give some guidance here for runoff coefficients. And these are well-known tables that we've referenced in here. I think these are from Caltrans, but they do give like single-family homes 0.3 to 0.5. And so I picked a middle of road value there. You can do a more detailed analysis of that, but I'm using a runoff coefficient of 0.4. And now, with that data there, with the distance from Sacramento, that gives us a DMA unit basin storage volume of 0.32. And this table comes right out of the guidance document that shows how to calculate this. And these are the tables that are provided for the rainfall for these runoff coefficients. So to do a reality check, we are somewhere between Sacramento and Redding. And we're somewhere, our runoff coefficient is between 0.25 and 0.50. So we should be somewhere between 1.8 and 0.44 or 0.32, exactly where that number should be, to show you that it's right on line. So this step 5 then summarizes the 2 features that we were using to look at this. And it shows that under the Casca method, which was the steps 1 through 5, we have a required capture volume of 181 cubic feet. And under the urban runoff quality management approach, which was basing off the impervious area calculation working on the side, it's 164. A slight advantage to the developer. Really not much of a difference, but slight. And so that's what our bioretention for that particular site needs to be sized to. All right, just a couple more slides and we'll be done. So for this regulated DMA project, we had we had met it right here. This is the slide I wanted to get to. Our design volume DMA, and I need to correct it because I corrected the trees, is 99 cubic feet. Our DMA that they calculated there is 156, and actually it looks like they need to up it a little bit more. So we need a little bit more bioretention storage volume because I had too many trees, or they need to plant a few more trees. All right. Now there's, so we talked about selecting and sizing the BMPs. The next step is incorporating hydromodification measures. And I'm going to go over these real quickly. These are the only standards when it comes to designing a post-construction plan or a bioretention cell or infiltration trench. these are the only standards given by permit in it. And so review some of these. Needs to be sized to treat the volumetric criteria or the flow-based criteria for that control measure. The maximum surface loading rate of the infiltration facility is 5 inches per hour. Minimum surface reservoir volume equal to the surface area of the infiltration facility times the depth of 6 inches. The minimum planting depth this is important. It needs to be 18 inches, and it even gives some specification as far as what does the planting medium need to be, and percent sand and organic material. Subsurface drainage storage area needs to be, it's typically gravel with an area equal to the surface area having a minimum depth of 12 inches. So that's your rock layer. Now an underdrain, it requires an underdrain with a discharge elevation at the top of that rock layer, so that if that fills up, then it can take the excess off-site. And then no compaction of soils beneath your infiltration device, no liners or other barriers that inhibit infiltration, and then appropriate plant palette for specified soil mix and maximum available water use. Now that last one, that's exactly what the permit says. I'm not quite sure exactly what they mean by that, other than I think what they're saying is if you're going to have a system that can be fairly saturated at times, your plants need to be able to withstand that. Or if there's going to be times it has lots of saturation and other times it's going to be very dry, you got to have be using a plant palette that can handle that. And then there's one other hydromodification requirement is for larger sites, regulated projects that create or replace 1 acre or more of impervious surface must incorporate site design and treatment control measures that prevent the post-project runoff from exceeding the pre-project flow rate for a 2-year, 24-hour storm event. Now, the permit says this does not include projects that do not increase impervious surface area over the pre-project condition. So if it's equal or less, then you don't have to meet this hydromodification goal. But if you're 1 acre or more of impervious surface and it's an increase, then you do. Now, what is that figure? Well, Rich actually gave me a website that we have linked in here in your notes that you can go to and actually type in your location and come up with that number. You'll have to specify that you're looking for a 2-year, 24-hour storm. But roughly, if you run it for Chico, and Chico's kind of in an interesting area because it changes rapidly. Other places in the valley, it's pretty consistent. But Chico, it could range anywhere from 2.5 to 2.75 inches, thereabouts. And then the last thing to do is to prepare the submittal. And that's this document that you've been following along, this worksheet. And basically, this will be a part of their submittal. There's a lot of other things that will be submitted, the plans, the calculations, stamped by the licensed professional. And if they're using any proprietary systems, they're going to need to have cut sheets of what they're installing. And so there's a whole list of things on the back sheet of this worksheet that says what's required at the time of submittal. But this will really be a tool that the plan checkers will use to evaluate the submittal, and then also ultimately, if they get audited by the EPA or by the State Water Board, to show that each project went through the process. All right. Well, when I first discussed having this workshop with Rich and Angela, we talked about a 4-hour workshop. And I think there was a lot of wisdom in having a 4-hour workshop, but we didn't know how many people would actually show up to a 4-hour workshop. So we are just at 2 hours now, and what we can do is have questions afterwards. You have my contact information at the bottom of that sheet. So if you have questions, if you're a municipality, have questions, I know Oroville has some questions, or folks at Chico, or you're a developer, you're having to actually do this for a real project, then we have a saying in our office that advice is free over coffee. So you pour yourself a cup, call me, tell me to pour me a cup, and we'll have a chat. I won't charge you for that, but if you want us to do your entire plan, then yeah, but we can have a chat, we can walk you through that. Definitely, there is going to be a lot of questions, but that is how to submit or how to prepare a post-construction standards plan. Hopefully that was helpful to you. I know it was a sprint, but thank you for being here today. All right.